Now we talk about diagnostic tests. So once you fit the model, it is important to check your assumptions. So the first assumption is that there is no serial correlation between the error terms. So all these diagnostic tests are carried on the error terms. So you know that, say you have 3 correlated error terms, and you know these are coming from the same distribution with variance covariance matrix. So what this serial correlation test does is it tests whether this variable at time t is anyway linked to the variable at time t minus 1. So what you expect is that the shocks are independent in time. So these shocks are independent at t minus 1 and at t. So this is the fundamental assumption, that between t minus 1 and time t there is no correlation, and obviously at time t between different variables there is correlation. So there is no serial correlation. Serial means in the series of time there is no correlation. So this is what serial test will do. So you reject the null hypothesis if this serial test gives you a p-value of less than 0.05. Then there's an arch test. So this arch test simply says that there is no heteroscedasticity. That is, the variance of these error terms is not changing over time. So there is no heteroscedasticity, and you reject the null hypothesis if p-value is less than 0.05. So basically this variance covariance matrix is not a function of time. So as time changes, you're expecting the variance to remain constant. Therefore there is no heteroscedasticity. The final one is normality test. You obviously want these 3 variables to be normally distributed. So these errors are normally distributed, and you reject the null hypothesis only if the p-value is less than 0.05. And for our estimated model, we will see that we will always get p-values more than 0.05, and therefore you do not reject any 3 of these hypotheses. So our error terms do satisfy all the 3 assumptions. So let us run these 3 tests: serial test, arch test, and normality test in the R package. So let us run the serial test first. So you run the serial test. Serial test is run. This is Portman-Tew test. P-value is 0.6. So you do not reject the hypothesis. Then you run the arch test. P-value is 0.9. Again, you do not reject the null hypothesis that there is no heteroscedasticity. And finally is normality test, and the normality test p-value is 0.15. So again you do not reject it. So you only reject the null hypothesis if the p-value is less than 0.05. In all 3 cases we see that the p-value is greater than 0.05, so you do not reject the null hypothesis.